Hi everyone, my name is Steve Song. I'm with the Internet Society, and this video is intended to introduce you to some of the tools we've been developing to use the Open Fiber Data Standard. The Open Fiber Data Standard, if you're not familiar with it, I encourage you to check out ofds.info. It is a common language and framework for describing terrestrial fiber optic networks. We're not going to go into the details of that in this video. This video assumes you have some familiarity with the standard and are interested in the tools themselves for mapping fiber. Now, when it comes to mapping fiber, there aren't that many good tools out there, but one of the more popular ones is Google Earth. And most of you probably are familiar with Google Earth. It's an amazing tool that you can use to capture points, lines, polylines, polygons in the keyhole markup language, or KML, developed by Google. And Google Earth Pro is a free tool. It works on every platform and it's quite easy to use. So it's not really surprising that many operators use the Google Earth in order to draw out maps of their terrestrial fiber infrastructure. And one of the challenges, however, though, is that while it is very good at allowing you to draw those lines and points, it doesn't capture much in the way of metadata, right? So you can't really structure a kind of database around your map. And so you can have the map, but you can't really have all the fields that you might want to capture. And that's really what the Open Fiber Data Standard is intended to do, is allow you to build maps of fiber in a very, very structured way. However, uh, Google Earth remains very useful and still a good way to get started with mapping fiber. And so, what kinds of problems might you run into in building, say, like this is New Zealand, and we wanted to map the national fiber optic backbone? It's not obvious how you would get started in drawing that map. And you may have seen the website for Chorus, which is here, in which you can see that they have a small map of their national fiber optic network. And in fact, you can zoom in a little, and you can see it's still, it's a PNG file. It's a fairly simple image that you might want to somehow translate all this information uh, onto Google Earth. Well, there is an easy way to do that, and that is you can add an overlay. So if I go down to add overlay image and browse for a local image, I've saved a screenshot of that map on my computer and I'm uploading it. And you can see now that it has overlaid that image over Google Earth. And if I make that image a little more transparent, you can begin to see how the map itself, the image map, overlays over the map on Google Earth. And you can kind of move things around until you get a reasonable overlay of the map of from Chorus over Google Earth's map. And once you have that, you can begin to effectively trace the map in Google Earth. So here's one I built earlier. These are a little more refined images that I've overlaid over the New Zealand map, and you can begin to see where the routes are for Chorus. And in fact, if I enable the roads on Google Maps, then as I zoom in, I can begin to see that the routes that I see on these purple lines that are part of Chorus's map are probably following roads, and I can begin to simply trace those roads and add data points as for instance here, Timaru. I can actually add that point exactly where that urban center is. And so that's a very easy way to start. And I can show you I started building it up here and begun to add individual routes and points. So uh, we can add another point. It For instance, here at New Plymouth, I simply click on the point icon and say, I'll give it the name, uh, New Plymouth, and then move that icon around until it is centered over the Metro Center in New Plymouth. Now you can be as accurate as you want. Because our source map isn't accurate, there's not much I can do. I'm just guessing roughly. So now I've added that, and as I zoom out now, I'm going to want to connect some of the lines that or the fiber routes from an existing point to this new point. And so I can choose the line string or polyline. In OFDS, we call them spans. And I can begin to draw. And again, here you can be as detailed as you want. I'm just going to give it a little bit of color here so that it's more visible. And here I can begin to draw that map following the road. Now, there are ways that you can be even more detailed about this in terms of following the road, but this is because the source data isn't terribly refined. There's no need to try and be too accurate here. But and so here we are. I've got another line. And so once I've begun to do this for the entirety of the chorus network, I can then begin to save this as an exportable KML file. And an exportable KML file is useful because you can import it into other systems. You can use it in Google Maps. You can import it into GIS systems. However, again, with this metadata, there's very little that we can capture. There's a name, and then there's a description, but there's no structured data. And so this is what we're going to try and address with the Open Fiber Data Standard. And we've built a tool that allows you to take a map that you have built in KML, just like the one that we were building there, and convert it into the Open Fiber Data Standard. So you can go to this URL, which is KML to OFDS.opentelecomdata.org, and we can simply browse for a KML file. Now, in this case, I'm going to choose one from somewhere else. This is the UFINET network in Nicaragua that I traced a few days ago. And we can see it's now selected. And now I want to give the name a network, the network a name, and we'll call it UFINET National Network Nicaragua. And we can say, whether is this a planned one? Is it operational? You can choose that. It gives you a kind of default name for the output, but you can choose that. And then it captures additional information such as, well, who actually operates the network, or owns the network. So the name of the network may actually be different from the owner, but in this case, it's the same. It's UFINET, and the network provider is UFINET Nicaragua. No, these are all very similar, but as I say, and in different places, they may all be different. Now, the script that we've built that converts KML does its best job to kind of guess what, sometimes points are not completely located on top of the lines. Sometimes the lines have breaks in them. And so we've done our best to guess what is being done in the KML in order to produce the best OFDS output. But you can tweak these options, and there are instructions there on how you can tweak them. You can also tell it to ignore specific points on the network. So some KML files capture all of the manhole or handhold data on fiber networks, and if you want to ignore those, you can put the names of all of the handholds to ignore using regular expressions. But for this, we're just going to go straight ahead and convert it, and it gives you a little progress marker showing you how it's doing in terms of parsing the KML, breaking up the KML into individual segments between each node, and checking for any missing nodes. And here we have the downloadable file. So and a preview. So this is a quick check to see if everything's going okay. And here you can see it's got the points of presence with the names associated with them, and indeed the spans that connect them. Now, when we download these files, they come in a zip file, and inside that zip file are two different kinds of files. So let's take a look here quickly. And they are GeoJSON files and a JSON file. Now, JSON is the kind of lingua franca of the internet in terms of sending any kind of structured data or database information over the internet. JSON is the language you typically would choose to do that, and there are just thousands of tools designed to process files structured in a JSON format. Now, GeoJSON is an extension to that format that captures geographic information. And the reason we give you both of these formats is that the Open Fiber Data Standard involves different tables capturing different kinds of information. So there's an operator table that captures all of the information about the operators. There's a network table if you have more than one network that captures multiple networks. There are spans which capture the routes, and nodes tables that capture the points of presence. Now, these all have relationships with each other. It's a relational database. And all of that kind of relational structure is captured within the JSON file. But that JSON is not really ideal for rendering a map easily and quickly. So we output the information into GeoJSON format as well to allow you, if your focus is on just getting a map that you can display that carries the basic information, then GeoJSON is maybe the way to go for you. And indeed, that preview map you saw was built from these two GeoJSON files. However, if you want to build a foundational resource that that allows you to edit and maintain detailed metadata over every aspect of the network, then working with a JSON file is what you want to do. And in order to do that, we've built another tool. And that tool is a plugin for an open source GIS platform called QGIS. Now, QGIS is a hugely popular open source GIS program. It is designed, it's an extraordinarily powerful tool that can do many things with geographic information. And perhaps that's one of its downsides is it is a little intimidating in terms of the various features that it can do. But its very power makes it very useful if you are trying to build a sophisticated resource for mapping terrestrial fiber. And that's why we built the plugin for that. Now, in order to install the plugin in QGIS, well, first you have to install QGIS as an application, and it runs on everything, on Windows, on Mac OS, on Linux. So you have your choice. And then you, in order to install the plugin, you would navigate to our plugin page. It's currently called OFDS a QGIS plugin, but it's shortly to be renamed OFDS Studio. It's something a little bit catchier. And you simply download the zip file from this page, And within QGIS, then uh, go to the plugins page and simply choose to install from a zip file. And if you pick up that file from the zip file and install it, that's all you have to do. And so here I've already done that, and we can see that the Open Fiber Data Standard plugin is right there. It's activated. And and this is what that means. This is what that looks like here. You can see up at the upper right-hand corner there in these black squares, there's a plus sign, a little map with an arrow, a little check mark, and a little export icon. So that's what we're going to use now to work with the map that I just exported from the KML to OFDS converter. So the first thing to do is to create a geopackage file structure. And so GeoPackage is it's a database. It's a SQL database designed for GIS data, and so it is well understood by QGIS, but it's also well understood by other commercial platforms such as ArcGIS. And you can see it's created this structure for us here that captures some of the things I was talking about before: the organizations, the networks, the nodes and spans. And so we have a blank canvas to work on now, but we have the structure in which to store our information. And now that was built with this first icon here, the plus sign that kind of creates the framework. Now I can import data. And so I'll go to the place where I just downloaded this data and select the JSON file. And now we're not seeing anything at the moment because we're a little too zoomed in. But and that reminds me of one thing we want to do here is also create a background for this data. So if I and now I'm just going to add a Google Maps background to this, which is very easy to do in QGIS. You simply add it as a layer, and I'm going to put the open fiber data structure over top of that. You can see these operate as layers on the left-hand side. And now we can zoom in. We know where to zoom in. And here we have the Ufinet fiber network for for Nicaragua. And, you know, there are very easy things to do in QGIS, such as adding labels to the nodes. And so you can see where, you know, confirm that the names have been correctly applied. But also now I can begin to edit and add more metadata to those. So for instance, each of these nodes contains additional information, such as if you want to capture the street address, or if you want to indicate what kinds of resources are available at this area, sorry, at this node. You know, for instance, is it an access point? Is power available, for instance? And you can capture that information for all of those nodes. And you can also then do the same thing with the network. If you want to capture more information about the Ufinet national network, you can put in a website. You can, and quite critically, I think here, indicate the collection date, the publication date, and the level of accuracy in this map. In this case, you know, I think we would put say that the accuracy is relatively low. And also indicate things such as, you know, the language of choice. Not only can you edit those tables as you know, as a database, but you can then begin to manipulate the network itself. And so here you can see that, well, I've sort of followed the road in drawing this map, but I haven't really done an amazing job in following the road. And so by selecting it and choosing one of the node editing tools, I can begin to add a little bit more nuance to the network and bring it so that it is closer to where the network actually is. And you can do this and be as detailed or not detailed as you like. This is totally up to you. And it is something that can evolve over time. So you might start with a very basic map, um, but you may, improve its accuracy with time and add information about it with time. And it can be a resource that grows and improves over time, which I think is, I don't know, it's very appealing. I think in terms of rather than trying to redo things every couple of years, this can be a living data resource that can be exported into a variety of formats. Now, here there's a button to, oh, well, no, before we go there, let's validate it. So there's a validation tool that checks to see whether it is consistent with the Open Fiber data standard. Now, in this case, there are a couple of things that need correction, but I can take my time and correct those things and make sure that if I share this with anyone else, it is going to be completely consistent and machine processable by any tool that can handle OFDS. And I can export it directly into the changes I've made. I can export it as my updated network uh, right here and save those changes. You can also save it directly as a QGIS project. If you want to continue working in QGIS, you can save the whole thing there. And having built this map, I can also add additional maps. So if I want to, for instance, add other regional maps, for example. So if I want to add Panama and I want to add Costa Rica, then if I zoom out, you can see here I have fiber for the entire region here. And that also can be exported as an individual project that can cover multiple networks. And you can see if I open my network table here, we actually have three different networks now captured in this. Now, having done that, if you received a file that was in OFDS format, you might want to check it out. And so, in order to check it out, we have a validation tool which is called Cove or Convert, Validate, and Explore. And I can simply browse, and a bit like the KML to OFDS tool, I can choose an OFDS JSON file. In this case, I'm going to choose a network from Kenya, submit it, and it will go through the entire data set, validating that the data output is consistent with the Open Fiber data standard. And as I say, with any tool you build that works on OFDS, if it passes this, will then work on everything else. Now, in fact, we have found an error here, and that this is a recent data set, but it's just an improperly formatted field that is easy to correct. And similarly, you can see it's generated a map down here. And what is nice about this conversion tool as well is that it doesn't just check the data, it gives you the data back in different formats so that you can download the GeoJSON files if you want, you can download it as a spreadsheet or as comma separated files. And so those are the basics. The URLs for these various sites will be in the description field, and I encourage you to try these tools. And if you have questions, reach out to us through ofds.info, the website, and we're happy to help. Thanks for taking time to listen to me today.